solve the following system of equations. X squared plus y squared equals 9. X squared minus y squared equals 9. And let's see. So to solve this system of equations, um, you can use substitution, but occasionally elimination would actually work out, as long as you're eliminating the right kind of term. So for instance here, if you'll notice, if I took these two equations and added them together, I would have 2x squared, the y's would cancel, and that would just be equal to 9. Oh, sorry, 9 and 9, of course, would be 18. Now, dividing both sides by 2, that leaves me x squared equals 9. And if I take the square root of both sides, then I have x equals plus or minus 3. Now do be careful. Make sure when you take the square root of a variable that you consider both the positive and negative counterparts. All right, so that gives me two potential solutions here. And to figure out what the y values are that associate with each of those, I can just plug back into either equation. So the first equation, I'll just use it for no particular reason. If x is equal to positive 3, then that would be 3 squared plus y squared is equal to 9. So 3 squared is 9, and therefore if I subtract 9 from both sides, that would cancel. So that gives me y squared equals 0, or y equals technically plus or minus 0, but that's of course just 0 itself. So one solution is positive 3, 0. And then if x is equal to negative 3, well, it kind of looks like the same thing will happen. So when I plug in x is negative 3 into the first equation, so the x changes into negative 3, then that gets squared, plus y squared equals 9. So negative 3 squared is also 9. So when I subtract 9 from both sides, I still end up with a situation with y squared equals 0, or y equals 0. So negative 3, 0 is another solution. Now these two types of equations, the top one was clearly a circle. The second one's one you haven't run into before. It's called a hyperbola, and the shape could potentially have as many as 4 different intersection points between these curves, but you don't really need to know that to do the algebra. So keep that in mind.